412 sequences. So sequences are just sort of a list of numbers that have a particular rule that make the list. Yeah. So they're a whole lot like functions we've been doing, right? Like the rule for any function is the equation itself, right? Like 5x plus 2 tells you get the next number, right? By putting an x in there, multiplying by 5 and adding 2, yeah?
Isn't that what we're doing again?
Sequences? Not really. It should.
When you did
Oh, yeah, I know.
squaring, you would make us do like 2 plus 2 plus 2, or 2 times 2 times 2.
I don't know that had to do with this.
No, but it looks like the same thing.
We'll see. Okay. But anyway, so sequences are kind of important to learn now because any of you that move on to, say, a higher math, you're going to be dealing with sequences in series, which are sums of sequences, and they have significant importance in higher math. So sequences are just another way to talk about a relation or a function, okay? So what a sequence is, it's a set of inputs and domains. It's basically a list of numbers, okay? And you notice here they have them, a list of numbers in a sequence using the set notation, okay? And each term of the sequence is each separate number, and we number each term with a term 1, term 2, term 3, 4, etc., right? Okay, so if we look at exercise 1, here is a sequence of numbers, 4, 8, 16, 32, etc., right? And we call the numbers, the list itself, an A. I'm going to draw like a little chart around this, okay? And I'll call these all the A's, and this is the N, like the number of the term it is, the first, second, third, right? And I'm just going to, I'm going to draw the, so 1, 2, 3, 4, 5, 6, 7, right? First, second, third, fourth term, etc., all the way to the seventh term, okay? And if we want to refer to like any specific term, and they'll use different letters from time to time, but right now we're going to use, say, like A sub n, okay.
We have cows in
So we can identify any given term by using this kind of notation here. A sub n, right? So like A sub 1 would be the first term, A sub 4 would be the fourth term in the sequence. Simple enough, right? Or sometimes you'll see it like this, A parentheses n, right?
Oh.
Now either way, it means the same thing. You'll see it in both ways. But when we use that A parentheses n, it looks a little more like function notation, right?
Yeah.
So then we can operate a little, right? So it's so either one of these is the nth term in the sequence, okay? In the sequence. Okay, so it's not too horribly confusing, I don't think, right? And now each term in the sequence, there's a rule that gets you from the first term to the second term to the third term, etc., right? So real quickly, let's look at these. Find what's A of 3, or the third term, okay? So that is 16, right? Now the A1 plus A7, what's A1?
4,
And A7 is 256, right? So 4 plus 256, of course, is 260, okay? And A1, A sub 1 is the first term, which is, that should say A2, actually. It's a typo, because we just did that. Well, anyway, A2 it should say. What's it, the second term? 8.
8.
This isn't very hard, is it?
No.
And then A1 squared, which is what? 4 squared, which is 4 squared, 16, yeah? How about part E? What are the two numbers we're subtracting?
16.
minus 32, which is I'll wait here.
Negative 26.
16 minus 32, yeah. Negative 16. And now we want to solve for n, right? So that's where, what do you mean solve for n? That's just the number of the term, but that's easy, right? They gave you the term, so what's the number in the sequence?
6.
6. It's 128, right? N equals 6. Okay. About what? Get the what? The n? They're just saying, okay, which part?
Like, what would you subtract, or why would you use the numbers on top? How would you do that?
Well, we're just saying, this is our sequence, these numbers here, right? And the sequence has a first term, a second term, a third, and we're just saying, this one's the first, that's the second, right? That's the n. We just call the n the number, it's like it's place in line. That's all. The n is just a place in line. Sometimes you might hear it called the index, actually. Right, but it's just its place in line. Okay? That's all it is. All right. So now we're going to talk about it being functions, like I mentioned before, right? And so now in exercise 2, you see we have something that looks a little more like the function notation, right? But n is just the term's place in line. Okay? So what are we going to do? Consider, so write out the first 5 elements or first 5 terms of this sequence, okay? So what would be the first term? If we have a of 1, and this is going to work just like functions now, right? So it'd be 2 times what?
1.
1 plus 1. This is not hard, right? What is it?
A of 1 equals 3.
So A1, the first term is 3. That's all it says, right? The first term is 3. And they want the first 5. So A2, the second term would be 2 times 2, right? Plus 1, which is 5. You getting the idea? So when you guys finish this out for the last 3. Just do that. So what are those terms, guys? Let's list them off.
Wait, I'm not done yet.
All right, I'll put 3, and then I'll put 5, and then you tell me the rest. You're missing one.
3, 5, 7, 9.
But are you seeing a pattern anyway?
11
Isn't this just like,
plus 2.
yeah, you're right. So isn't this just like constant rate of change? Doesn't it look like a linear function? With the slope is 2? Yeah? Okay. So it's like the difference between this and an actual function is like the n is the number, its place in line, so it starts with 1, right? And then 2 and 3, etc. Okay? All right, now they want us to graph the sequence for n going from 1 to 5, which we have there right now. I got to ask you a question before you start trying to graph this thing. Are we going to plot these points and then draw a line through it with the graph? Why not? Well, what does the line indicate when you have it on a graph? Yeah? Like if you connect 2 points of the line to the graph, what are you saying? There's in-between values, right? Are there any in-between values here? No. Right? It's just these itself. So we're only going to plot the actual points, right? So from 1 to 5, here's our n, right? There'd be 1, 2, 3, 4, 5, right? Place in line. And we've got, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you go, we got enough room, right? 2, 3, 4, 5, 6, 8, 9. Okay? So it'll be 1 comma what? 3. 2 comma 5, you get the idea? And then the 2, and then 5, 11. Right? But understand, we're not going to connect that with a line because there are no in-between values. They ask it right here, why should we connect the plot of points with a straight continuous line? Okay? Because the n is just their position in line, right? You're not going to be, there's the first person in line and the second person in line. Is there the 1.5 person in line, like the 1.5 spot? Does that make sense?
No.
Just to you? You're the only one that doesn't make sense to? Does that make sense to you? The thing I was just saying about your place in line? You could be the first, second, or third person in line. Is there a 2.5 spot in line? No, right? There's no in between these whole numbers, right? So we'd say the position in line n is a whole number. Okay? So it is not continuous. You get what I mean? Like when you draw a line, it means continuous. It goes from 1 to 1.001, 1.00, right? So it is not continuous. And so I have a word here that you need to know. It is called discrete. Okay? So discrete's like the opposite of continuous.
I thought that meant like secret.
Well, that, in common grammatical usage, yes, but mathematically, it means one whole number right to the next whole number with no in-between values, okay? It's called a discrete function. I had to take a whole math class in graduate school called discrete math. It's all about math like that. Huh? What part are you missing? Well, did you understand up here what a sequence is? And we just say its place in line? Have you ever been in line with a group of people? Could you count that maybe you were third in line, or you were fifth in line, or and somebody was sixth behind you? That's all these numbers are up here. And when I say, if I say A of 7, it just means the 7th place in line, which is this guy, 256. That's all. Okay, that's it. And then when we graph it, this just becomes our x-axis, the place in line, and the y-axis is the output. You know, if it's a lunch line, we go over 3 and up Hannah, I guess. Right? You're the output if you're in the lunch line. It's just a different type of line, that's all. Okay? All right. Well, Bertie, what is the 21st term of the sequence? Well, geez, do we have a rule? Well, yeah. So we just do A of 21 equals 2 times 21 plus 1. What's 2 times 21?
42.
Plus 1? 43. So we have a rule, which is just like a function, yeah?
What do you mean show how you write it?
I just did. Didn't that just show it? That shows it to me, it shows it to you, right? I mean, you probably feel compelled to say something else after that, but remember, math is a language, yeah? We just said it. It's a whole sentence we just said there, right? Isn't it? Subject and verb. Direct out. So this, we defined this sequence up here with this equation, right? This function rule. Okay? And we call this an explicit rule, okay? This is what we call explicit, where it kind of like gives you an equation. Maybe you can just like think of the word explicit equation, right? But there's another way to define a function rule, okay? So this is explicit, it's an equation, okay? The other way to define a function rule is to use a recursive formula, okay? Don't get scared. We can define it recursively, Okay? So all that means is they give you what the first term in the sequence is, the first person in line, right? And then that's followed by a rule that tells you how to get the next person in, to get the next term in the sequence. So they just give you the first one, and then they give you the rule to get each one after that. Like add 3 to each one. Does that make sense? Okay? So for a recursive formula, you're given the first term, okay? And then a rule to find the next term. Then a rule to find next term. Okay? And you just keep following that rule as far out as you need to go, for the number of terms in the sequence. Okay? And now sometimes I won't use n for the place in line. Sometimes I use I. You see this where they're using I? Okay, that's fine. Either I or n. It's like it almost doesn't matter, right? But most of the time you see I or n. But you can tell by looking at it, right? It's the next thing in the line. So what we have here is if I say like I or n, the I term, right? Whatever that place in line is, I'm just saying we're talking about the current term. Right? Like maybe I is 5, so we're talking about the 5th term. That's the current term we're talking about, right? That's an I. It's like a little person I, so it doesn't look like something else, right? Now, let's say I is 5. You're the 5th term in line, right? So if you're the 5th term, what is the term that's right before you, the previous term? Okay, but let's say we don't know what's 5. Let's just say we're talking about the current term I, so what's the place in front of the ith term? Well, I don't know the number. What did you do to the 5 to get? Yeah, what did you do to the 5 to get 4? Subtracted 1, right? So if you see I minus 1, that means the previous term. Okay? But what if you want to talk about the next term? I plus 1 just refers to the next term. Right? So if I is the 5th term that you're looking at, then I plus 1, the next term would be 6. Yeah? The 6th one. So here is a recursive formula. Okay? So B sub 1 is 7. That's our first term. Okay, so the sequence, the first term in the sequence is what? 7. Remember, that's its place in line. That's what's in line. Okay? The first term is 7. And now we have a rule to get all the next terms. Okay? So this says B sub I would be what? The current term, the one you want to get, equals what? The previous term plus 4. So that's the rule. So to make this sequence, you start by writing what? If you wanted to list out the numbers in the sequence, 7, right? And then to get to the current term you're thinking about, right, the second term, it's the previous term plus 4. Yeah? Does that make sense? So part A, give a common sense interpretation for this recursive function rule. Well, right now, right out of the gate, we can say the first term is what? First term is 7. Okay? And then each term after is found by doing what? Each term after is found by adding what? Adding 4 to the previous term. That's it. All right. So what's all those symbols mean, right? So I is, or it could be N, right? I or N. I is the term you're currently looking at and want to know. You go back to the rule and say, what's the rule? Well, that term here, the ith term up here that you're looking for, says you just take the previous term, the term right before it, and add 4 to it. That's it. Okay? So let's write out the rule for the first 4 terms. Well, anyway, let's just write out the first 4 terms. So we know B1, don't we?
It says except B1.
I'm going to write it. I want it there. B1 is 7, yeah? Okay. Now, the next term, B2, is found by taking the, taking the previous term. What's the previous term?
7.
And doing what to it?
Subtract 1 and add 4.
No, just adding 4. No, that's, okay, guys, that's not, you're not ever going to subtract 1. That just says the previous term. I minus 1 just is talking about the term right before it.
Oh.
Remember, I is its place in line. Just giving it a number. So B2 would be what? So what's the number? 11. Okay. Now B3, again, the term we're looking for is the previous term plus 4. So 11, previous term plus 4, which is what? 15. So then the 4th term would be what? 19. Okay? So you kind of get the recursive rule?
Yeah.
They just tell you the first term, and here's the rule to get every term after that. You just, the rule, the first term is 7, and this just says each following term is the previous term plus 4. So you just keep adding 4 to the previous term, and you
So
got your
if on the
sequence.
bottom it was like I plus 1 instead of minus. It was
I plus 1 just means the next term. I mean, that's another way to write a recursive formula,
Still
right?
do the same thing, though, right?
It would mean the same thing. Sometimes they'll just state it in terms of the next term. They'll say like b of I plus 1 equals b of I plus 4. So yeah, we'll do a couple. You'll get it. Yes, the Fibonacci sequence. It's a famous mathematical sequence. But anyway. So they're back to using n's again, okay? And they're using like the function notation, right? So take a look at this recursive definition. What's the first term of this sequence? The first term, A1, is what?
And 2 equals 1.
The first term. This means the first term. And what is the first term that we list off in the sequence? 1. And what does this mean? The second term is also 1. So we start out with 1, comma, 1. Yeah? Not too hard, right? And now we have a rule to get each term afterwards. Okay? So to find the term we're looking for, the nth term, we take what? What term is that? That's not multiplying, guys. What term is that? The previous term. N minus 1 is previous. If it's the n, remember, that's its place in line. Again, if you were 5th in line, this is talking about the person who's what in line? If your place in line here, n, is 5, what place is this person in? The 4th spot in line. And then what place is this person in? The 3rd place in line. So basically, aren't these the previous 2 terms? Right? So the sequence says you get the next term by doing what to the 2 terms before it? Adding them. Guys, this is not our operations here. That's just telling you the place in line. That's the place in line. That's the point. So A of 5 would be the 5th term in the sequence. Right? if you're talking about the fifth term in the sequence, then an minus 1 is which term in the sequence? Fourth. And then a of n minus 2 is the which term? Third. Right? So you get the fifth term by adding the third and fourth term. That's all. Okay. Good. A little easier. Okay.
He's been Kermit Frog.
Yeah, well, helps me from exploding. I mean, let's continue. So how do you interpret this recursive rule? So the first two terms are what?
One.
The first two terms, A1, first term, A2, second term, are 1. Okay? And each following term is found by doing what? No. Each term after, yes, is found by adding what?
One. Like the place.
The two terms before it. That's all. Again, if it's fifth in line, then you add the two terms before it, the third and fourth, by adding the two terms before it. Alright? Let's go to part B, just list them out. Alright, so A of 1 we know is 1, yeah? In the second term, I'm going to use subscripts instead of their notes, right? Because they both mean the same thing, right? You with me on that? So A sub 2 also equals 1. There's our first two terms, right? How's this way, guys? So we got two terms of the sequence. Now let's find the third term. How do we find that term? Why are you saying minus?
Plus 1, or 1 plus 2, 1 plus 1.
It says to add the two previous terms, right? So what are the two previous terms? 1 plus 1, which equals 2. So now let's go to the fourth term, A4.
2 plus 2.
The two previous terms, 2 plus 1 equals 3. Let's get the fifth term.
3 plus 1.
You getting the idea? No, the two previous terms.
2 plus 3.
Well, I'll do it the same order. 3 plus 2, yep. Which equals 5. Now the sixth term. Now what's, for this one, what's the two previous before it? 5 and 3.
8.
So 5 plus 3 equals 8. You get that now?
Yeah.
So all this rule says is your first two terms are 1. Why do they have to give the first two terms because of this rule?
Because you have to add.
Yeah, you can't even get started on the third term because the rule is to add the 2 before it. So they needed to give you 2 to start with. Does that make sense? Right? And all the n minus 1 means is the previous term, the term right before it.
I get that.
Place in line right before it. N minus 2 is 2 places in line before you. N is its place in line. Okay? You guys, I will say, are definitely, without question, one of my classes.
Yes.
Whoa.
We made the list. Yeah.
Yeah. Congratulations, everybody. You're in the room. All right. Exercise 5. Kirk is trying to train for marathon. Let's see if this looks like a sequence. His first month. Does that sound like the first place in line?
30 days.
Anyway, not necessarily. Okay. Does that sound like the first place in line for a
Yes.
sequence? Okay. He runs how far?
5 miles.
5 miles per workout. And then it sounds like a rule for each successive thing, right? Then he's adding what?
2 miles per workout each month.
For each month, for each place in line in the sequence afterwards, right? Are there going to be any in-between values?
No.
No, he's adding discrete numbers of miles each time, right? Not continuous, okay? So let's fill out the table. We're using a rule here. So month 1, he runs 5 miles. Month 2, how many?
13.
It's the
7.
It's the previous term plus what?
3.
Okay?
Oh, 7.
5 plus 3
8.
is 8.
Oh.
Not the
I
previous
always do
place,
that.
not the previous place in line, the previous term.
So then this would be
11 miles. And then 14, and then 17 miles.
I always accidentally say like for 5 plus 2 and 5 plus 3, I accidentally always just say 7 or 5 plus 3.
We'll fix that.
I try not
Okay.
to do it.
All right. For B, let's give a recursive definition, a recursive formula for this. So recursive formula, what do you list first?
The first term is 5.
The first term. So let's do it with a notation. Everybody look here. How am I going to write the first term? I don't want to do it with parentheses.
1 to 5.
A sub 1 equals, first term is, everybody got it? That's the first term, it's 5, comma,
Plus 3.
now I want to give a rule to find each term after. So the term you want to get now, after that, is going to be what?
Are you using 3?
Okay, if I'm talking about the nth term, how do I talk about the previous term?
N minus 1.
A sub n minus 1, and what do we do to that term, whatever it is?
Add 3.
Plus 3. There's a recursive formula. You list the first term, and then the rule to get each term after that.
6 negative 1, is it, what is that?
A sub n minus 1, the previous term. And is the term you want, and you get that by taking the previous term and adding 3. Yeah? Okay. So now they want to graph it between 1 and 5, right? 1, 2, 3, 4, 5. What are they counting by here? 2, 4, 6, 8, 10, right? Okay. So for an M, I guess you're using M instead of N. 1, we do 5 miles, so in between there, right? And then 2 was 8. And then 3 was 11, way. And then 4 was there, yeah. And then 5 is 17, like this. Are we going to connect it with a line? Because drawing that line indicates in between values of miles. It's discrete, not continuous. You understand that the line means continuous, okay? Whew. All right, you kind of get the idea? The A sub n, or the A parentheses n, or I, just is referring to its place in line. What number in line are you, right? And the result is the actual number itself. Sure, hang on a second. All right.